All right, it is October 13th today. Hopefully we end up getting to circles and arcs, but if not, it's okay. So we should have 7-4 out, angles of elevation and depression, so that we can finish checking this and then have 7-5 ready to go, because we will check that next. Brian, lock it. Go! Good Lord, if you could bring your math to math, that would be really convenient.
Yeah, it would.
I'm going to start charging you when you go to your locker.
Brian said a pencil.
Dude, you would be rich.
What? Not that you'll ever actually pay me back, but I'll just figure out how much you end up owing me. If I charged him $1 every time he had to go to his locker, do you think he'd care?
I'd give him a pencil.
I think he'd end up
Like 30 minutes later, it's gone.
And then, but I gave him a nice mechanical pencil. And then he left it on his desk. And then Todd took it off of his desk. And then Todd had it. But I really loved that pencil.
I'm sorry.
But now I got that. It's nice. And then
Please tell me that these beats belong to one of you guys. Making sure.
wait, can I sit at the tall desk? I know I'm going to steal it.
Any questions?
Can I use one of those chairs?
Yeah, I don't want my 7th graders because they fight over them.
Thank you. We're a special class.
Oh, let's play it.
I heard none.
I have questions about the last four.
Yeah.
The last 4. The angle of elevation from A to B and the angle of depression D from B to A are given. Find the measures of each angle. So what we're going to want to do is kind of draw a picture to make this work. So we elevate from A to B, and that makes angle E. So if I use these words as my horizon, just to make life easy, I have no idea if we're drawing this to scale, because we don't know anything really yet. So do not trust what it looks like, trust the math that we do. And this is angle E. And then from, and the angle of depression D from B to A. So now, since it's from B to A, angle D would be right in here. Does that make sense? Or does anyone disagree?
I just don't understand it.
How do you get the value?
So hold up. So then, if E is 3x plus 6 and D is x plus 20, well, what do we see about E and D? They're alternate interior, so they should be. So they actually are, these answers that are here are the size of the angle. I don't think that answer is solving for 47, 30. No, I think this is the size of the angle if I set these equal to each other, solve for x, and then plug back in for x. So just to check, let's do one. So if this was 3x plus 6, and then my blue angle E was x plus 20, I can combine my constants on this side and get 14. I can combine my variables on that side and get 2x. X would then be equal to 7. When I plug 7 back in, the angle size is 27. Because it says find the measure of the angle, not solve for the variable. Any other questions? Just set them equal, solve for it. Be careful with your distributive whenever we have the coefficient out in front of a binomial. Rhea?
Can you do 20 and 22?
20 and 22.
I think I just solved the wrong angle on 20.
An airplane flying at an altitude of 10,000 feet. The airport, which is scheduled to land, is 50 miles away. Now the problem is it didn't tell me whether it's 50 miles horizontally or 50 miles direct distance. So when you guys set this up, what's up, gents? Said what's up?
I lost my pencil and yeah.
So I've heard that your organization sucks
It does.
to not sugarcoat it. I'm going to give you this pencil today. If you still have this same pencil tomorrow, I will give you a prize.
Sweet. Why the heck are you rewarding him for doing something everybody else should do?
Because it's not going to be a very good prize, but he needs to learn some organizational strategies. Huh?
I will come back with
Jesus.
Okay.
Come back with this pencil every day of the school.
So when you guys set this up, hold up. Here's the other tricky part. That this might be where your mistake came in. This is feet. This is miles. Did you convert your miles to feet? Ah, so you're going to need to convert your miles to feet before you do this. Did you use that as your horizontal distance?
That is a good question.
Well, see, that's what I'm trying to figure out is whether we use it as our horizontal distance. But if I convert my miles into feet, that'll be 50 times 5 tomatoes, or 5280, and we get...
Oh no, actually, I did convert it. But
So 264,000?
No, I got 264. I forgot to add 1,000. Never mind.
So, if then, and obviously this is not drawn to scale. Now, I'm still not certain, but I'm assuming that 50 miles away is talking about a horizontal distance. Did anyone solve it using it as the hypotenuse distance? Okay, because if we get the wrong answer, then we got to flip it. But I believe most of my test questions are a lot more clear on which side it is. So if it was here, then we have 10,000 for my vertical and 264,000. They want the angle of descent. So they want to know what is this. So really, I still have 10,000 over here. I still have 264,000 up here. Tangent, we use opposite adjacent. So essentially, I'm going to set up the inverse tangent of opposite over adjacent. I'm not certain, but hopefully that works.
Oh, I just wish I did I did the opposite.
Yeah, I get 2.16, or approximately 2.2. It says round to the nearest degree.
Okay.
I think I must have solved for a different angle or something. I ended up getting like 88.
You solved
I got 88 too.
You solved for this angle.
Yeah, I said I did too.
So think about the problem we're solving. If a plane took an angle of descent from the horizon of 88 degrees, that is not good. If a plane takes an angle relative to the horizon of 2 degrees, nice, gentle landing.
You could.
You can choose which plane you want to be on, but I'm taking the second plane.
You could do the pelican.
Yeah. And then the
Or a baby dragon. Of course.
Almost as like.
Any other questions? 7-4.
Yeah, same.
Armenia's boat and access ramp for boat chairs. The main entrance is 8 feet above the sidewalk level. The architect designs the slope of the ramp in such a way that the angle of elevation, so from the horizon, is 5 degrees. That looks like 50, but it's 5 degrees. You guys know it's 5. So then, how long must the access ramp be? So we are solving for this side, or my hypotenuse. We know the opposite, so we can use sine. Opposite over hypotenuse,
Why is it 5?
because my angle of elevation
Oh, I thought it was 50. Never mind.
was, yeah, I said it looks like 50, but you guys know it's 5.
I
So
wasn't
it's funny that you
paying
said that.
attention. It's okay.
No, I know, my degree sign is too big. I know it is. Like, I agree with you. There we go. But now it just looks like a dot. But either way.
Good enough.
Can't be perfect. And when I do 8 divided by sine of 5, 91.7, or about 92.
It's like I had a calculation error. I don't know what I did. I ended up with 115.
Yeah, that would have been a calculation error because the hypotenuse is going to be the longest side. So if you actually solved for the horizontal there, you get a smaller value than 92.
Where did the calculation
Other questions? 7-4. All right, 7-5.
What was that one called?
That's really long.
G or K? We did K, didn't we?
Yeah, okay.
You're lucky we didn't do G. It's like 10 more questions.
Are you serious?
That's why I chose K.
Thank you.
I did it on purpose.
I love you.
I didn't just like flip a coin. What am I going to do tomorrow? Roll the die.
Yeah.
Shake the magic 8 ball. So remember, we want to solve each triangle individually and then multiply up by how many triangles of that size you have. So whether you deal with the right triangle or whether you deal with the isosceles triangle in each of these, that's up to you. Any questions? 1 through 3. Let's just start real easy, those top 3. Your light's on in case you care.
I don't care.
Eventually, those batteries are going to die.
Yeah. Calvin, I turn them on.
Somebody might crash into you if your headlights don't work.
Exactly.
I was on the highway last night at like 8:30, and there was a car driving with no headlights, no tail lights. Like when you and this is the dangerous thing about when you start driving, you don't necessarily notice because all the street lights, you might not notice that your headlights aren't on. But like this car kept flashing their lights at them, trying to get them to turn on their lights because the fact that you don't have any tail lights on, that gets really dangerous. Questions 4 through 8.
Can you just turn them off, or do they not work?
Some cars, they're automatic. Some cars, you have to turn them on or off. And then other cars, you can turn them on and off, but if it senses that it's dark, it turns on like front running lights that are either called running lights or fog lamps, but it still doesn't turn on any back lights. So you could have front lights turned on and still no tail lights on. You know what I mean?
Yeah.
And then tail lights and brake lights are 2 different things. Brake lights always light up when you brake. Tail lights only light up when you turn them on. 4 through 8, nothing? 9 through 12. Lynn, did you do all the Post-its on that mirror in the hallway?
No, but I added a few.
Nice. I like what you guys are doing. It's pretty awesome. You have a question? Sweet. 10. 10. So, find the area of each regular polygon. If we have a regular triangle, what kind of triangle is that?
But then I don't know. I had trouble putting it in the calculator.
Okay, so hold up, back up. If we have a regular triangle, what type of triangle is that?
Equilateral.
Equilateral. So I know that each angle is 60.
16. No, never mind. Continue on.
So this top angle would be 30, and this angle would be 60, which makes my apothem my long leg. To solve my short leg, well, it's already solved for me. Because if it's an equilateral triangle, this edge must be 16.
But that's not the apothem.
Sorry, okay, I'm getting there. My bad. I said it wrong. I agree with you. I said the wrong name. But I know that this is 8. So this is really my angle bisector. If I want only apothem, we can deal with this. And I can't remember if we looked at, I might have talked with somebody about this question.
I split it up into 3.
Yeah, so you did this.
Yeah.
And then the apothem's the short leg.
Yeah, so that's one option. Or if I don't use the apothem method just because it's a triangle, I could just use base and height. If I solve for the altitude or the height of the triangle, then I can use that method. Do you want to take the apothem way? Is that what you're asking for?
That's what I did.
So if that's then this angle, I'm just going to notate this one that you know that both of them are the same. That angle would be 30. So this angle would also be 30, which means that this top angle is 60. So my long leg is 8. And a 30, 60, 90, how do my legs, sides, whatever relate? Because it's got the 30 degree, what do I know gets used? Caleb?
The long side is, well, whatever the short side times radical 3.
Right. Now how does the hypotenuse get found?
It's twice the short side.
Yeah. So in my head, how this makes sense is 30, 60, one of them's double the other. But I can't think of that as direct correlation with the legs because my hypotenuse is twice my short leg, which here is the apothem. So 8 is actually radical 3 times something, and that something is my apothem. So to find my apothem, it's 8 divided by radical 3. Which one I do? 8 divided by rad 3. 4.6.
Is that a good answer? Like that's.
I mean, I get 4.618, so if you want to be specific, you could just say 4.62.
Okay.
And then from there, you can derive the perimeter by tripling 16.
348.
Now, the other way that I was going to take, because I actually think this is easier and depending on how you feel, if I drop this side, and I know that this is 8, well, I see here, based on, like we talked about how we could prove the 30, 60, 90, my hypotenuse is double my short leg. So my long leg will be radical 3 times my short leg. So it'll be radical 3 times 8, or 8 radical 3. And then I could just do 8 times 8 radical 3 and get my answer that way. I actually think that's a quicker method. But that's because that's how my brain works. So it's all up to what your brain thinks is easiest. Other questions from the front? Ethan?
This question's about just, like, pretty much everything in general. Like, why is the apothem, like, 10? Why isn't it the whole height?
So the apothem is always the distance from the center of your shape, vertical or perpendicular to your edge, out to the edge. The radius, or radian, depending, is the distance from that center, kind of came out crappy, from the center to the vertex. So any regular polygon can be broken up like this. In a triangle, it looks kind of weird because to break it up and give it a center point, I make an apothem here, an apothem here, and an apothem there. Now that looks really weird. So to think about this and make things simpler, we really look at this as being 3 triangles that we've made, where the apothem is the height of this bottom isosceles triangle. So if I find the area of this small triangle, I can multiply by how many of them I have and get that area. Same thing here, except my colors are inverted. If I find the area of this red triangle, I can multiply it by 6 and find the area of the whole thing. So the reason that we use the apothem is to find the area of any triangle, I have to use the formula 1/2 times base times height, and that's your apothem.
Okay.
So giving this a second to marinate, soak it in. So any polygon this works for, because I can find the angle measures based off the interior, like the amount of edges. And I know that my interior angle will be 360 always because it's an entire circle. So like here for the hexagon, I break this up and I say this whole angle is 60. So what would this smaller angle be? 30. Since I've made a right angle, this must be 60 then. And that solves really nice because I have 30, 60, 90. I know that this edge would be 8 because it's going to be half of the 16. That's a nicer solving one. But if we go to a problem like 12, it's still a hexagon. Do we have any that aren't hexagons? Let's find a pentagon or something.
They made it easy on my.
Yeah. I chose the easier homework. So like 16 is a bit more difficult because the apothem here would be that from the center. It's your altitude. So I know that my hypotenuse of my triangle is 12. Now if I use that same method that I can use in any polygon, what's the interior angle at your vertex? Or at your center, sorry. 90, so this will then become 45. And then I have a 45, 45, 90. How does the relationship work in the 45, 45, 90? Because you have 2 angles the same. How's that 2 come into play? Yeah, but...
I was going to say, isn't the long side, isn't it the short side times radical 2?
the hypotenuse is
hypotenuse.
radical... Well, it is your long side
Well, yeah.
because there's only 2 lengths of side. It's radical 2 times your short edge. Well, your edge, because there's only 2 other edges and they're the same. So that 12 is radical 2 times x, and I divide by radical 2 to find out what x is. Now in this case, I can actually manipulate it a little bit differently because my apothem is half the edge length, and then I could find the area of the square just by knowing the edge lengths. But that's up to how you want to solve it. How's your brain want to take it? I love your shirt. That's very cool. Yeah, not
It
yours,
freaked
Kayla.
out. I was like, you can see
No,
my shirt.
Michelle's shirts. Or Emma. What is it even? Are those Pokemon things?
Yeah, it's like
That's what I
it's
thought.
a bunny and then it's Pokemon and also Pink Floyd.
Yeah, Dark Side of the Moon reference. Because prisms do really cool stuff with light. That's actually, Mr. Estes was just talking about this yesterday, how his one daughter who's in college just bought a new camera because it takes video a lot better than the previous one because it uses a prism instead of a mirror. So that's where the math of like advancing, when I know how things refract when they come into a mirror directly reflects, right? A prism will refract as opposed to reflect. So it changes how the image looks. It's a lot clearer and crisper.
Wait, does it also affect like the photo quality?
I'm not certain. She said she bought it mainly because the video quality was like noticeably different. Yeah. Yes, I do. Ooh, I hope I do. I may have run out. If I'm out, Mrs. Goldring for sure has them. Goldring. Go say hi to. Hi, Miss Goldring. I have like antiseptic wipes and I have gloves and stuff, just no band-aids. Michelle? 15. If we had an 18 gone. Now, it asks, find the measure of the angle formed by two consecutive radii and a radius and a side of the given regular polygon. So if I think of an 18 gone, I can essentially draw one isosceles triangle. That would be the middle of my, or like a slice of my 18 gone. So then I can figure out what this interior angle is by knowing 360 divided by how many edges? 18. So we get 20. Then if I drop my altitude or an apothem, that cuts that in half and makes that angle 10. And the radian goes to the vertex, to the edge. Well, I know that my apothem meets at a 90 degree, so this has to be the complement, and it's 80.
Okay.
Does that make sense?
Yeah.
So really just think about one of these slices of the polygon. Other preguntas.
Oh,
Bria?
can you do 22?
Your friend printed a picture of a regular 18 gon. She wants to cut the 18 gon into right triangles. She divides the figure into 36. That's actually really, really funny because it is the same sort of thing as up here.
Oh.
So if we think about cutting the 18 gon into the right triangles, those will each be half of the isosceles triangles, which you know because an 18 gon would have 18 of those isosceles slices. If we get 36 right triangles, they're each just half of it. So we have that middle angle of 20 degrees, which when I chop it to a right triangle becomes 10 degrees, and then this base angle has to be 80.
Wait, I'm confused. Why does that have to be?
So picture an 18 gon, but this is the center of the 18 gon.
Yeah.
The whole angle around is 360. So if I divide it by my 18 slices, I get 20. You with me to there?
Yes. Yes.
Then I can drop an altitude, and because I knew this angle was 20, it now has to be 10. The altitude has to be perpendicular. I love that moment.
Thank you.
I like that's what made me like grow a love for mathematics is those moments of like, oh, it makes sense. Like that whole like it has to make sense. Quite frankly, most other topics Like, where in the world should I put my comma? How do I use a semicolon? Like, I don't think those are as rigid right wrong as math is. So that's why I kind of like fell in love with math. Yeah.
23, the second part, like the difference.
Math teacher has an equilateral triangle with a radius of 6 inches and a square with the same radius. I bet you it's how you drew it. So, the equilateral triangle with a radius
Oh, that is
of 6 inches.
No, I got that.
Okay. So, which figure has a greater area? So let's just deal with the triangle first. That would also be 6. So that is really my hypotenuse. And if I, so I'm going to draw on top of stuff. I hate doing this, but we know most of our info. So actually I'm just going to slide this over. This is not a very good equilateral triangle. My apologies. So if it's equilateral, I know that each of these is 60. So this now becomes 30. So my apothem is now my short leg. I know that my hypotenuse is double my short leg. So my short leg must be 3, or my apothem must be 3. My long leg is radical 3 times the short leg. So this will be 3, radical 3, for just that short leg. So if I, and actually, do we know the height of this triangle? Like the entire altitude? We do. The question is how. Do we know this distance? It's 6, right?
I know.
So 6 and 3, I know my height is 9. I can actually just use half of the base times the height. I can use the formula for any polygon, but triangles are easier than just any old polygon. And guys, you never actually have to use that formula. So if you forget the formula, screw it, doesn't matter. You never actually have to use that formula. Derive one triangle, multiply by how many of those triangles you have inside your polygon. Which that formula does that, it just does it in like a really effective, quick manner. So, do you need me to do the square, or do you see it now? I'll do the square. Yeah. Square, same radius. I hate that. And that's obviously a rectangle. Square, same radius of 6. So now my apothem right here, but now I know this is a 45-degree angle here and a 45-degree angle there. So I know that my hypotenuse is actually radical 2, because I have two angles the same, so we use radical 2. Radical 2 times my leg. So to find my leg, I have to divide 6 by radical 2. I get 4.24. Or, yeah, it rounds down. And then actually, if I want, that's just half my edge length. So if I know the area is length times width, it's 8.48 is my whole edge length. And I just multiply those together. Did you have a question? Or?
No, I just grabbed it.
Does this make sense now, Michelle? Calvin.
Technically, you wouldn't even need to round your radical, because if you put it into the formula, you'd get 2 radical 2's multiplied together.
Yeah. So that's if you use the formula, you get a more precise answer then. I agree. But actually, if I'm working in my calculator, I'm never going to like clear an answer. I'm going to keep my numbers carrying forward. So like if I had this 4.2426400687, that's accurate out to like the millionths place, or actually I think further than that. So then I could just say times 2 to get the whole edge length, and then squared to get the area, and I get a perfect 72. Because my calculator has those values, just at the screen limit, it chops it off. So that's if you leave your values and let them roll, you'll get nice accurate answers.
I thought of a
Okay.
For the area of a square,
Okay.
4.5 times the apothem. I think.
I'd want to test it.
Well, because the apothem is half the length of a side, so there'd be
So we have apothem times 2. Well, give me the side length. And then it has to be times itself, though, right?
Wait, never mind, I messed it up.
So wouldn't it be like 4 apothem squared?
I messed it up. Never mind.
I think we could do it like if we knew the apothem. I think my area would just be 4 apothem squared. Wouldn't it be?
Right.
Wouldn't it be 2 apothem squared?
I have to square both of these.
Oh.
So, because this whole edge length is double my apothem, and then I multiply by itself double my apothem, so it's like 2a times 2a. Right, so 4a squared, I believe. That could work. Not that we need it. We don't do squares that often using the apothem. But very cool stuff. Other questions, 7-5. Rhea.
Can you do 25 and 26?
I would love to. An equilateral triangle is a perimeter of 18. Find its area to the nearest 10th. Equilateral. Try to draw this. Means that each edge is 6. So, from knowing that, I can drop an apothem. I can draw a radius. My long edge here is going to be 3 because I know it's half of one of the sides. I then know that my short side, because we knew these were all 60, so I know this is a 30, which is why I know this is my short side. My short side relates to my long side through a radical 3 multiplication, so I actually need to divide by radical 3 to get back to my short side. So 3 divided by rad 3, if I actually hit the division button.
1.732.
Yep. So we get 1.732. Then I can apply my formula if I want, because I know my perimeter already. Does that work?
Yeah,
that far enough?
that's good.
So it's all just setting up the one small triangle and deriving what we need from there. You said 25 and 26, right?
Right.
26, logo for company is a regular hexagon inscribed inside of a circle. The logo will be painted on the side of the company's office building. The radius of the circle will be 8 feet. Find the area of the hexagon to the nearest whole foot. So since it's inscribed, I know that if I took one of the hexagon pieces, my circle would come around like this. So it having a radius of 8 feet is really the edge of my isosceles triangle, because I don't know the length of this edge, but I do know that this is regular hexagon, so all of these radii coming out will be the same. Question?
Yeah, isn't there a formula to find the arc?
Yeah, but we don't need the arc.
Okay.
There is. There is. We're getting there next chapter. Or this chapter. If you think we're getting there in chapter 8.
Alright.
From here, I know that hexagon makes me have 60 degrees in that top angle at the center. With me to there. Which then lets me know that if I drop an altitude, that would be 30. And that is actually my apothem, because if you think about the entire hexagon, this is where I get screwed up with whether that's the apothem or the altitude. I appreciate every time you correct me, I really do. Because I only teach this one time a year. I don't get that much practice. So this is my apothem now, because technically there's a whole hexagon like all up around. Yeah, I got cut off by the board and then it all fell apart. But, so that's my apothem. I know that I have 30 degrees right here. I have 60 degrees right here. So my short edge is right here, and my long side is right there, and I know my hypotenuse. How can I use knowing my hypotenuse to derive one of the other pieces? Caleb, you beat her to it?
Alright, you would know that the bottom little short side right there is, divided by 2, that it's like 20, times 2 to the bottom side is the hypotenuse. Wait, half? Oh, half.
What
That's
you said is
that's
right.
what the word
No,
was.
what you said was right. You said times 2 to the bottom edge is the hypotenuse. You just said it kind
I
of tripping
forgot
over
the
yourself.
word.
So,
Half is, thanks, Elmo. Half of 8 is the bottom, and the bottom times radical 3 is the long side. Boom.
what's it even asking? Find the area of the hexagon of the nearest whole foot. So, again, with me talking about you never need to use the formula, if I forget the formula, can I still find the area of this triangle?
Yes.
Yeah, it's 1/2 base times height, right? We've been using that formula for a while. I have my half base. I have my height. So I'm going to get 16 radical 3 when I do half the base times the height. And then how many of those triangles do I have? 6. So I get 16 radical 3 times 6. So really it's 16 times 6. I get 96 radical 3. Or I bet that comes out to be 166. Times radical 3. Yep, 166.277 if you round it the thousandth place. Other questions? Let's not move on to chapter 8 because why? Like we have 8 minutes left or something like that. I'd rather show you your test for tomorrow. So this is what's going to be on the assessment. Unless I tweak it anymore, but I don't think I am.
Wait, so this is like the exact test?
So you can start writing stuff down.
No. I need your eyeballs. I need your hands not moving. No keypads typing. No anything else. And I'm going to stop the recording because Pearson might be mad at me if I start showing their tests to all of the internet. Now, I don't really care that I've been showing answer keys for practices, but tests are a little bit different.